let's take a look at one other question here. And then we're going to get into, like I said, all of those different types of rate word problems that are more difficult than these. And again, I'm not going to give you the notes from, I'm going to give you the notes as we go along so I can really prove to you that we have a lot to learn. And that's why tomorrow's class is going to be even better than today. So with that, let's take a look at this one here. And I'm going to read the whole thing. Again, the first thing to focus on is the question, but let's just read the situation real quick. A motorcycle travels at a rate of 110 miles per hour for 30 minutes. And the question says, how far did the motorcycle travel? Okay, let's just take a look here. How far did the motorcycle travel? Everybody, let's just take it nice and slow. What are we looking for in this problem? And how do you know? Come on, how do you know? Give me 2 reasons why you know. I'll sip some water and wait. Right, that how far gives it away. Let me use a different highlighter here. How far did the motorcycle travel? And then I see the chat box here saying the answer choices. The answers say miles. Miles, miles, miles. That is distance, right? My ASVAB party people, hope you're enjoying the math party so far. Just wanted to remind you before we continue that we do have a way for you to practice everything you need to get the ASVAB score that you want. Because in our math boot camp, we have everything you need in terms of recorded lessons to go through the entire concept. On top of that, we have guided practice, printable worksheets, and speed drills for each and every single mini concept, from adding and subtracting decimals to fractions, distance, rate, time, word problems, proportions, everything you need. It's all lined up for you, and it makes learning as easy as possible, and we make updates to this course on a weekly basis at no extra cost to you. So I really urge you and implore you, go ahead, check out the link in the description for the Math Bootcamp, which is also included in our full program, and we make it as affordable as possible. So go ahead, click the link in the description to learn about this more. That way you know exactly what's available to you to raise your score. I don't want you to feel test anxiety. I don't want you to feel like you're lost and you're just hoping for the best. I want you to take control of your studying, and the ASVAB All-Access Program and the Math Bootcamp are the exact ways to do it. So if you have any questions, my contact info is also in the description. But before we continue, please check it out so you know exactly what's available to you. That way you can feel confident that there is a solution for you. Let's get back to the video though. Let's ace the ASVAB. That is distance. A rate would be like miles per minute or miles per hour. A time would be hours or minutes or seconds or days. That is just straight up miles. So before we continue, everybody, can we agree or disagree? We're looking for distance. How far, and the answers being in just miles gives it away. Cool. But so far, only using what we said, how far and miles, are we guaranteed yet, like before we look at anything else, are we guaranteed that this is a rate word problem before we look at anything else? What guarantees that this is a rate word problem, everybody? What guarantees it? Yeah, the word per. That up there, the 110 miles per hour, the fact that we have a rate in this problem, yes, that's what gives it away. Remember that. We can't be, we can't get cocky and say, oh yeah, we're looking for distance, so there must be a rate. No, because this could literally say the motorcycle traveled 50 miles, then 30 miles. How far did it travel? That's adding. That's an addition problem. Here, we know it's a rate problem because we see a rate. So let's just write this down here. We are looking for the distance. And everybody, the distance is going to be in miles. Just make sure to kind of just take a note of that. Sounds good, Dominic. We'll see. We'll see. All right. So then up next, let's take a look at the information and let's identify, again, the 3 steps to word problem success. What's the question? Identify those keywords and what they mean. So the information. And then build a plan. What's the connection? You go in that order, in that exact order, you give yourself a fighting chance. So step 2, let's look at that information here. It says, oh, a motorcycle travels at a rate of 110 miles per hour. So two things really give it away here. Two things absolutely give it away. Rate and the word per. Both of those give it away. So here, rate 110 miles per hour. And then it says over here, 30 minutes. Everybody, what kind of a unit is that? 30 minutes, what kind of unit is that? Yeah, it's gonna be time, absolutely. That's gonna be time, 30 minutes. That is time. All right, so I wanna ask the question here. I wanna ask, a lot of us might understand that, yeah, the formula is distance equals rate times time, right? We might be feeling pretty excited about that. We know that D equals R times T, and we might be looking at this saying, okay, I'm looking for the distance, so I'm gonna keep that the same. My rate is 110, and my time is 30 minutes. And when I do that, I end up getting something like, 110 times 30, if I do the math, that's 3,300 miles. Who here got 3,300 miles? Who here looked at that and said, I got to do 110 times 30? And I'm feeling pretty good, right? Man, that's a lot of me's. That's a lot of yeses. Sounds good. Hey, cool. So, so there's this thing called dreams that can get broken sometimes, and let's make sure that those don't get broken for you. Welcome to a quick little math lesson with Coach Anderson Duran. All right, who can point out the difference here between this problem and the other problems that makes this setup wrong? Taylor, thank you. Taylor Boone says, the units aren't the same. Remember, everybody, just a few slides ago, I told you, I said, hey, yo, your units need to match up. If your rate says miles per hour, your distance is miles, your time is hours. You have to be consistent. In this case, you are not consistent. The reason is, take a look here. Take a look. Miles per hour, 30 minutes. They are not the same. They are not the same. So, for those of you, it's all good. It's all good. Hit me with the brush, hit me with whatever, punch some drywall, do what you got to do. But let me first explain to you, before I teach you how to do this the right way, let me solidify why this is wrong. Let me really help you out. Like right here, this is wrong. This is wrong. And let me really solidify this for you. Everybody, let's go ahead and say, let me just go through a different example for you right here. Let me actually just make a new page. And again, my goal, my purpose for this right here, this little detour is this. I'm going to teach you why it's so important that the units match up. Okay? Let me show you this. Quick question, everybody. Is it okay with you if I use, let's go ahead and say 60 miles an hour? Is 60 miles an hour something we recognize, especially when we're driving? Is that a number that we can recognize with rates, right? You can drive 60 miles per hour. I'm gonna help you visualize this, especially for those of us who have driver's licenses. 60 miles per hour, that's pretty fast, right? That's pretty fast. Let's go ahead and write this down here. Let's look at this pretend situation, okay? I'm gonna write it up top, pretend, just pretend, okay? Pretend that I have this cartoon car, okay? Let's pretend I got this cartoon car. It has no suspensions, no chassis, so whatever. But let's pretend we got this car and the rate is 60 miles per hour, okay? And let's suppose that the time it's traveling for, so here's the rate. Let's suppose that the time it's traveling for is, let's say some short amount of time. Let's say 2 seconds. Let's say it's traveling for 2 seconds. Everybody, let's find that distance. Let's just go ahead and pretend that we're gonna ignore the units just for a quick moment. Let me teach you why this is so important. So let's remind ourselves of the formula. Distance equals rate times time. This looks like a pretty easy problem, right? Okay, cool. I'm looking for distance. My rate is 60 miles per hour. The time that I traveled for was 2 seconds. Everybody, before I even solve this, let's think about this like reasonable people. Quick question, everybody. If I'm going 60 miles an hour and my brand new lemon, right, which is an oxymoron, but let's go ahead and say I'm driving 60 miles an hour, my brand new lemon, and I'm driving for literally 2 seconds. Literally 2 seconds. So literally I'm driving 1 Mississippi, 2 Mississippi. Okay, question, everybody. Do you expect this car in 2 seconds to travel a large distance or a short distance? What's your opinion? I'm driving 60 miles an hour, but I'm only driving for 2 seconds. Right? I think we can all agree. Look at that chat box right there, right? We're agreeing. This is a relatively short amount of distance. If you're driving 60 miles an hour for 2 seconds, I mean, you're not even going down the block. You might pass like a house or two, maybe 3 houses, maybe, but you're not going pretty far. So let me show you here. 60 times 2. We set up the formula. Let's see what happens. Everybody, what's 60 times 2? 120. Everybody, does it make sense on God's green earth that if I'm going 60 miles an hour for 2 seconds, is it reasonable that in 2 seconds I travel 120 miles? Is that reasonable? Is that reasonable? Am I on the space shuttle Atlantis? Am I on Elon Musk's new rocket? No, I'm driving a car. I don't expect to travel 120 miles in 2 seconds. I don't expect to travel the distance from Orlando, Florida to Tampa in 2 seconds. That is just not reasonable. That is just not possible given a car today, at least. So with that said, with this little example shown, does it make sense to you now that the answer will be wrong if your units don't match up? So write that down. The answers won't make sense if the units don't line up. So I want everybody to understand that, okay? I really want us to understand that. This will not make sense unless you make sure the units are the same. So we're not going to talk about fixing this one. We're going to talk about fixing the one that we're currently doing, okay? We're going to talk about fixing the one that we're currently doing. So let's go ahead and fix it right over here. What we're looking at here is we have 110 miles per hour and we're traveling for 30 minutes. So here's how we fix it. You simply convert the units. We want to make sure that we take the 30 minutes and turn it into hours, okay? We want to convert units into hours. Excuse me, we want to convert the minutes into hours. So here's how we're going to take care of this. We need to make sure that we have 30 minutes. And we're going to go ahead and turn that into blank hours. So there are a few different ways to convert, everybody. A few different ways to convert. But the first thing that we need to know to convert is understand, well, how many minutes are there in an hour? Quick question, everybody. How many minutes are there in an hour? Right, there are 60 minutes in 1 hour. So I can write this down over here. So 1 hour equals 60 minutes, okay? 1 hour equals 60 minutes. If you want to convert, this is a whole lesson that I have like 17 lessons on this. But if you want to watch one of those recordings, I may have one on YouTube that's already out. But if you're in the program, you know I have an entire section on this in your course. So just to have a brief reminder, a brief refresher, if this doesn't make sense to you, don't worry, you can watch the lesson later. If I'm going to convert 30 minutes, you simply multiply by the conversion rate. Conversion rate basically just says eliminate the old unit, keep the new unit. So if I want to get rid of minutes, I'm going to put the 60 minutes on the bottom right over here. And then up top, I'm going to put the 1 hour. Because if I have minutes up top and minutes on bottom, it's going to end up canceling out, leaving me with just hours. And that's going to be 30 over 60. And the thing is, once we divide and actually do 30 divided by 60, we're going to get 0.5. And I'm going to show you that briefly right here. So if I divide 60 into 30, I'll put some decimals just in case. Well, here's the thing. 60 doesn't go into 30, so you can just put a 0 there. Then you have 60 into 300. 60 into 300 would be 5. And that's it. That's just a clean division. And we have basically this being 0.5 hours, or half of an hour. And let me know if that makes sense, everybody. Is it true that 0.5 is the same thing as saying half? Is that true? Is 0.5 the same thing as saying half? Absolutely. Also, is 30 minutes half of an hour? Right, so just want to make sure that makes sense to you. Even if you didn't understand the whole decimal situation here, I hope you understand that 30 minutes is half of an hour, which is the same thing as saying 0.5 hours or 1 over 2, a fraction. Either way, all of that works. Again, I'm not here to teach all the unit conversions. I'm here to let you know that unit conversions could be part of a rate word problem like this one. It could be a very simple mistake to make, but a very simple mistake would make it wrong. I put the 60 on the outside because that's what we're dividing by. So with that said, everybody, you're good now. Now that you have this in hours, again, not minutes, hours now you're good to go. Now you can set up your formula. Distance equals rate times time. The distance we're looking for is the 110 miles per hour. That's the rate. Times 0.5 hours. And that will give you the correct answer. And so with that, let's go ahead and do the math. 110 times 0.5. Remember that when you're multiplying by decimals, just multiply like normal and then bring the decimal back at the end. 0 times 5, that's going to be 0. Let me zoom in for everybody. So 0 times 5, that's 0. 1 times 5, that's going to be 5. Then over here, the last one, 1 times 5, that's going to be 5. And again, you bring the decimals back at the end. So here we have one decimal place that we moved. Let me use a different color, a little more bright. And so we bring one back. And so that's 55 as the answer, or 55 miles. Yeah, 55.0 is 55. And so that would be 55 miles. Joshua, absolutely. Unit conversion is important. Absolutely. Because unit conversions could appear in percent problems. It could appear in a rate problem. It could be in a proportion problem. It could be in any problem. Like these ideas, these main ideas, like decimals, fractions, percents, unit conversions, negative numbers, order of operations, it can appear in any and every problem, every single one. Cool. Sounds good. Glad I can answer that. So Luisa, I'm confused why the 0.5 didn't match up with the 0 in 110. Oh, because when you're multiplying the place value, like where you kind of order it, doesn't matter. It's only with adding and subtracting. You got to make sure that the decimals are lined up, and yeah, you're good. Yeah, so it doesn't matter if with multiplication, no, it doesn't matter. All you got to worry about is bringing those decimals back at the end. Yeah. And everybody, so again, let's really make sure this answer makes sense. We're going to move on to the next one in a moment, but let's make sure that this answer makes sense. Everyone, if you're going 110 miles per hour and you're only driving for 30 minutes, which 30 minutes is less than an hour. Think about it. If you're going 110 miles an hour, that means in 1 hour, you're going 110 miles. That's what 110 miles per hour means. In 1 hour, every hour, you go 110 miles. Hey, really quick before we continue, if you're watching this, you've likely already been to one of my classes, And if you haven't been to one of my classes, remember to check that schedule. The link is right up there and in the description of this video. That way you can understand when my free classes are and my Access Program classes are. That way you can keep raising your score, knowing what topics we're doing, and get the job you want. So again, click there or in the description to see when the classes are and join one for free. I'll see you there, my party people. Let's get back to the action. If I'm driving for 30 minutes, everybody, if I only drive 30 minutes, can I expect to go more than 110 miles or less than 110 miles? Would I expect less or more? Right, we would expect less. If we're driving for less than an hour, then we would expect to go less than 110 miles because it says 110 every hour, per hour. So it would make sense that we travel less, 55 in this case. And since 30 minutes is exactly half of an hour, then you would be traveling half of that distance, half of that 110 in 1 hour. And half of 110 is 55. So it's another way that you can really reason with it in this case. So A, 55. So just want to, again, continue making it make sense with the math and without the math. Really want to make it make sense. So just to prove the point, or just to kind of recap it, yes or no, do you understand that the units need to match up when it comes to rate word problems? Okay. Cool. Sounds good. And even if it's just a little bit, don't worry, because in tomorrow's class, I will, let me see, because I have the 7 problems lined up. I will definitely insert another unit conversion problem. I absolutely will. I'll make it. I won't even tell you what's coming up. I'll let you get that practice in. Oh, no worries, Naya. This is the one problem I had planned here in the guided warm-up. What we're going to do now is we're going to get into the timed practice. We're going to throw ourselves into the wolves here. So as a reminder, everybody, there are 3 steps to word problem success. We know that we're talking about rate problems. We know we've taken these notes down. We're having a good time, hopefully. But when it comes to word problems in general, always 3 steps. Step 1, what do you want? What do you have? And what's the connection? You have got to make sure that those 3 things are true. Now, here's what's going to happen. Like I warned you already, and this is what's going to happen. We're going to be going over problems that we have not reviewed yet, not in today's class, at least. Now, does that mean I'm trying to discourage you from trying? No. I want you to do everything you can as if this is the actual test, to take these 3 minutes here for every problem and just do your absolute best. If at the end you have no idea what's going on, take a guess. Treat it like the test. Treat it like it's the last question on the test and you only have 3 minutes. So do what you can, follow the strategy, and we'll see where this takes us. Everybody, does that fall good with you? Even if the problem is unknown to you or confusing to you, you're still going to try your best. Okay, sounds good. I'm hoping that we can get at least 3-4 problems before time ends today. Boom. So here's a word problem example. I'm going to start the timer pretty soon here. But what we're doing here in this problem is looking at 2 different scenarios for the same person. Now you're going to have to find a clue here, but there is a clue that helps you solve this relatively quickly. So here's a 3-minute timer starting right now. So again, give it your best, treat it like it's the test, and then we'll go over this together. Let's get to it. And only type ready when you're ready. Don't reveal the answer. So let's go ahead and let's get this problem done. Everybody, first things first. What do we do first? Hit me. Let's go. Right. Read that question, man. Read that question. So here, starting with the question, give yourself the opportunity to not get confused by all these numbers. Right here. How long is today's bike ride? Sounds good. Everybody, what kind of a unit are we looking for here? What are we looking for? Yeah, for sure, Krista. It'll be up tomorrow morning. Yeah, we're looking for what? What are we looking for? And how do you know? What are we looking for and how do we know? Give a reason why. Support yourself. Right. How long gives it away? Also, the answer choices. Look at the choices. The choices say 7 hours, 30 minutes, 9 hours, 10 hours, 30 minutes, 18 hours. Everybody, all of those numbers in the answer choices represent or are examples of time. Every single one of them. So if you said distance, can you see that the answer choices, and you say how long is today's bike ride? You might be thinking distance, you might be thinking time. But if you look at the answer choices, that gives it away. That gives away its time. So you're looking for time. Yes or no? Do we agree now? Do we agree now? Looking at the answer choices, where we want time. And just to follow up, what time are we looking for? For what? The time for what? There's a very specific keyword that we're going to want to make sure we highlight. Yeah. Smalls, you had it. Today's time. Did anybody here notice that? Right here. Today's bike ride. Today's bike ride. Yeah, because guess what? The problem starts off with the word what? Yesterday. That's already instantly one way, even if you don't know how to do the problem, that's instantly a way for you to tell, yo, something fishy is going on. If the question's asking me for the information about today, but then the problem starts about yesterday, yo, right there, that's when you need to kind of heighten your senses and say, yo, there's two different scenarios here. On one hand, yesterday, on the other hand, today. Even if you don't know what that entails in the future, can you say yes, that you agree that there are two different scenarios here, yesterday and today? Even if you didn't see it before, do you see it now? That again, the question here is talking about today's bike ride, but the problem includes a scenario or situation about yesterday. So again, we have to be able to identify these differences. We really need to be able to identify these differences, because with that, again, we want time. We want the time. And again, that time specifically for today. So here's what I'm going to do, everybody. Here's what I'm going to do to give myself a much better chance. First of all, I'm going to zoom in a little bit to give you more room to see, but I'm going to split this problem up into yesterday and today. That's exactly what I'll do. So to do this, allow me to just move my face all the way over here. So allow me to kind of just get used to looking the other way. All right. So let me, because I got to give myself all the room in the world to kind of look over here. So let's look over here. And let's talk about here, yesterday. And then over here, today. And again, we want the time today. That's what we want. But I'm just going to say, yo, let's just take a look at the information. Let's take a look at the information and write things out nice and slow. So here we go. So yesterday, let me use my highlighter here. Yesterday, you rode your bike for 6 hours at an average pace of 18 miles per hour. Okay, everybody. So let's just go ahead and just take it nice and slow here. So we biked for 6 hours. Everybody, what kind of a unit is that? 6 hours, what kind of unit? Great, that's time. Now, follow-up question, everybody. Follow-up question. Is that 6 hours, does that belong on this side, yesterday, this side, today? Which column does it belong in? Which one does it belong in? Not both. Nope, not both. It belongs in yesterday, because clearly it says right here, yesterday, you rode your bike for 6 hours. So that 6 hours, that time right here, that's yesterday only. That did not describe today. We're looking for today's time. That's what we're looking for. Like, we are looking for that. How long was today's ride? We want that, but we're gonna find out how. Next up, no worries, Smalls. So with that, next up, it says at an average pace of 18 miles per hour. Everybody, what is that 18 representing? And give me a reason why. And no worries, I'm glad that some of you guys are private messaging me saying, oh, okay, I see why that's happening now in terms of yesterday and today. Cool. And again, this is what we have to get ready for. This is a problem of one object, two scenarios. We're talking about the same person, but at different points in time. Right, this is a rate, and we see that it says miles per hour. What's another word that gives it away? Average, what? Average pace. Pace, speed, rate, those are all examples of rates, yeah. So pace of 18 miles an hour, that is a rate, because again, the word per gives it away. And again, that belongs under yesterday's in the same sentence. So 18 miles per hour. Okay, let's move forward here. Look at it next. Next it says, today you decide to bike the same distance. So whatever distance is here, everybody, is it true that's going to be the same as the same distance here? Is it true? Yeah, they're going to be the same. They're going to be the same. These are the same distances based off of that text right there. That was so ugly. 1 second. Right here. These distances have to be the same, right? Because it says right here, you bike the same distance. That's where I get that from. So before I continue, I got to make sure that, because some people are taking notes as quickly as they can, they might miss this. Do you see that the problem says you bike the same distance? The yesterday's distance and today's distance are going to be the same number. Yes or no? Do you understand that? Okay, cool. Now let's see what else we got, man. What else we got? Oh, here it says, okay, so again, today you bike the same distance, but 6 miles per hour slower than the day before, or 6 miles per hour slower than yesterday. So everybody, is it true? Is it true that the rate then for today should be 6 miles per hour? Is that true? I love how the majority of us are saying no, and that is correct. The answer is no. The rate is not 6 miles per hour. Remember, you need to understand what these keywords and phrases are saying. Let's make sure we read it again here. 6 miles per hour slower than the day before. Exactly. We got to take the 6 miles per hour away from yesterday's rate. If I say 6 miles per hour slower than yesterday, isn't it true that you start with yesterday and then you take away 6? Yeah. That's what we need to do. So the way that we get the rate for today is going to be the 18 from yesterday right there. The 18 from yesterday minus 6 equals 12 miles per hour. So does everybody here understand how we got that 12 miles per hour? Because again, 6 miles per hour slower than yesterday. You take yesterday's 18, slower, take away 6. 6 miles per hour slower than yesterday. Yesterday was 18 miles an hour. Take away 6 miles an hour, you get 12. That's what that means right there. The slower, let me put an arrow, let me draw an arrow for that right there. So let's take a look here. Like I said earlier in today's class, I made sure to mention it as best as I could here. If we're looking for today's time, again, that's what the question is asking us to find. We are looking for today's time. If we're looking for today's time, I need to use today's rate and today's distance. Notice what I have so far. I have today's rate, that's the 12. Everybody, do I have today's distance? Yes or no? Do I have today's distance? No, I do not. I do not have today's distance, not yet at least. And this is where a lot of us need to be a little more savvy when it comes to word problems. A lot of the times, most of us will look at this and say, if I don't have today's distance, I can't solve this problem. But everybody, what do we know about today's distance? What did the problem tell us? Why is this highlighted green again? What do we know about this? Right, it's the same as yesterday's distance. Exactly, we said that, we saw that in the problem. The problem said you traveled the same distance. So this right here, let me go ahead and push that over. right over here. If we find this distance for yesterday, then we have the distance for today. Yes or no? Is that true, everybody? If I can find yesterday's distance, I can use that same number for today. And this is why it's so important to understand keywords. Yes, we're taking an extraordinary amount of time going over this problem, but I can guarantee you somebody here is learning something. So let's get it done. Let's find today's distance. I keep pointing in the wrong direction. Let's find today's distance so we can find today's distance and solve the problem. So here we go. To find today's distance, what I'll do, remember that it's going to be the rate times the time, which is going to be the rate being 18, the time being 6, these right here. And so 18 times 6. Let's find out what that is. Everybody, what's 18 times 6? 108. Let's do the math here. So it's going to be 18 times 6. So that's going to be 48. Then we have 1 times 6. So that's going to be 6. Add the 4 is going to be 10. So we have 108 miles. That's going to be the distance for yesterday. And like we said, that's going to be the same distance as today, 108 miles. Because now that we have this, guess what? Now we can fill in our formula because we're only looking for the time. We have the rate, we have the distance. So now what we can do is, yes, we can absolutely solve for this because distance equals rate times time. So we can say 108 equals 12, the rate, times time. And now all we have to do to both sides is get rid of that 12. Like I said, if you're looking for the rate or the time, you divide to get it by itself. And so here, I'll divide by 12 to get rid of the 12 on the time. And then we have our magical final answer. T equals 108 divided by 12. That's 12 times 9. And so that would be 9 hours for time. So as crazy as that problem was it fair? As crazy as that problem was it fair? Notice that we had two scenarios that were related. They had the same distance. So because we needed the distance for this formula, we could find the distance from this one to take it over and solve, but we just have to make sure we know how the pieces connect. And that's how we get 9 hours as the correct answer. Yeah, so dividing the 108 divided by 12, that's really going to be knowing your multiplication tables. If you're dividing by anything from 1 to 12, gotta make sure you know your multiplication tables because that's the backwards of it. Because you can do 12 times 7, that'd be 84, 12 times 8, 96, 12 times 9, 108, and boom, you would have it. But let's soak it in here. Take a screenshot if you need to. Let me go ahead and zoom in just a little bit here, and I'll let you take your screenshots. And boom, go ahead and take your screenshot there because it's 7:49, and here's what we're gonna do. At 7:49, I'm going to present you with one more problem. I'm going to give you the answer to the problem, but that's going to be one of the first problems that we lead off with in tomorrow's class to show you how to do it. Because I don't have enough time to show you the problem, how to do it, and go over the program for those of you that are interested. So I want to make sure I at least give you the last problem, which I typically don't do. So I'm going to give you the last problem, and then in tomorrow's class, that's the first type that we'll review. Okay? For the first type that we review. So hopefully everybody had a chance here to try that out. Yes or no, who here is interested in coming to tomorrow's class? Who here is interested in tomorrow's class? Ooh, hello. Okay, cool. Sounds great. So again, get ready for it. Let's go ahead and get into this next problem. Again, it's going to be another problem that you're not going to be possibly sure how to do, but I want you to try your best and try to think about it logically. Because when I show you how to do it, then your logic, your openness to logic with my explanation is going to come together and you'll be like, oh yeah, that makes sense. So with that said, let's go ahead and check this one out. Here you go. I'm going to give you 3 minutes. And if you're already in the program, you're good. I'm excited to see you tomorrow. So here it is. Here's the last one that we'll do. Let me get the timer up. Start the timer right now. And my ASVAB party people, just like this free video that you're watching, I have more free materials for you, and there's no excuse for you not to get them. I have a free practice test that comes with video solutions so you can learn from every single mistake. And on top of that, I have a free class on Zoom once a week, every single week for 2 hours. So imagine that. You got more free materials than just this YouTube video right over here. Let's keep pushing forward. Sign up right now, and I'll see you in the next class. Let's get started. With that, the answer here, without further ado, is this. It is A, 70 miles. And the key here is same place, same direction. That is the giveaway. I will tell you exactly why in tomorrow's class that tells you that the answer is going to be 70. But long story short, when you are traveling in the same direction, the rates are being subtracted because you're canceling out the same distance they travel. When they go in opposite directions, this one's covering this space, this one's covering that space. And so you add it together when they're going opposite ways. We'll talk about that in tomorrow's class, again, like I said. But with that said, who here feels like, hey, when it comes to the fundamentals of rate word problems, you are solid, you are strong. Again, identifying a distance, identifying a rate, identifying a time, knowing that the formula that you use is the same situation, not different situation, the same situation. And lastly, knowing that the units have to be the same. If it's miles per hour for the rate, distance is miles, time is hours. Like, who here feels like they have those 3 fundamentals down? Because once you have those fundamentals down, then we learn these crazy problems like this one, like the one before this one, where we had 2 scenarios with the same person. Here we have two actions in the same scenario. And then we can look at other situations where we have multiple actions within the same scenario. And so we both know this video just helped you with your test anxiety by just a little bit. And to keep lowering your test anxiety and keep raising your confidence, that's what my ASVAB All-Access Program is for. The link's right up here. Click it, watch the video on how it works, and you'll see exactly why thousands of my students have raised their scores and gotten the jobs they want. So click there, watch the video, and sign up to raise your score. I'll see you soon.